Okay guys, this is lesson 4, scaled relationships. Let's find relationships between scaled copies. 4.1, 3 quadrilaterals, part 1. Each of these polygons is a scaled copy of the others, so they're all scaled copies. Name 2 pairs of corresponding angles. What can you say about the sizes of these angles? So, corresponding angles, I can say that DCB and HGF, so angle DCB and angle HGF are corresponding. What can you say about the size of these angles? They're the same degree, right? And then I'm going to say DAB, angle DAB, and angle LIJ are corresponding. There are both corresponding angles. There's 2 sets, and then it says, what can you say? What can you say about the sizes of these angles? They're the same degrees. Or same measurement, right? Same degree measurement. Check your prediction by measuring at least one pair of corresponding angles using a protractor. Record your measurement to the nearest 5. So I'm going to check the DCB, right here, DCB, and HGF. So you line up your protractor right here. I start here, DCB. So actually I'm going to line it up just like that. This line has to line up here, and it opens this way. So it's going to go to 90 degrees. So this angle right here is 90 degrees. Same thing over here. Check to see if it's the same. Lines up right here, straight up. This angle right here is 90 degrees. And I bet you this one is too. Yeah, but it's kind of small, but it's also 90 degrees. So those 3 are 90 degrees. If you had a protractor, these ones, the J and the F and the B, this angle right here is 95 degrees. So this would be 95 degrees, 95 degrees, 95 degrees. The DAB and this one, the HEF and the LIJ, those 3 are 125 degrees. No, I'm sorry, these 3 are 125 degrees. These 3. This one, this one, this one, 125 degrees. And then the last one is 50 degrees. So this one right here. Degrees. So you have all the degrees. You can use a protractor. The way you use a protractor is you start with your angle. Just draw an angle, right? You have a center. The line should go on forever, both degrees. Right? We use these 2 lines right there. You line it up like this. And it goes from 0, right here, 0, all the way to 70. So this is approximately 70-degree angle. Okay, that's how you use a protractor. So that's above. All right, page 38, it says 4.2, 3 quadrilaterals, part 2. Each of these polygons is a scaled copy of the others. You already checked their corresponding angles. Number 1. The side lengths of the polygons are hard to tell from the grid, but there are other corresponding distances that are easier to compare. Identify the distances in the other 2 polygons that correspond to DEB and AC and record them in the table. So DEB is 4 and AC is 6. Where do they get that from? They're saying between here and here is 1, 2, 3, 4 units, and here to here, 1, 2, 3, 4, 5, 6 units. That's where it's coming from. So they're saying distance that corresponds to D and B is across. So in EFGH, this one, it would be across this way. It would be 1, 2, 3, 4, 5, 6 units. So HF is 6. And then straight up and down would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So that would be GE is 9. And then over here for this one, you have AC, which is straight up and down. So here will be KI Oh, I did that wrong, guys. I'm so sorry. I got them in the wrong spots. Let's do this. GE is 9. GE is 9, and then this is going to be KI. My bad. KI is 1, 2, 3. And then on this one, it would be LJ. Sorry about that. 1, 2, 2. So you have 4, 6, 6, 9, 2, 3. And then it says, look at the values in the table. What do you notice? Pause here so that you can review your work. So what should you notice in this? It says, these corresponding distances are related by the same scale factor, even though they are not side lengths. So it's the same scale factor from here to here to here to here and backwards, right? And these two, even though they're not the same, the side lengths, they're in the middle, right? They're the actual size of it, okay? All right, page 39, next one, number 3. The larger figure is a scaled copy of the smaller figure. So this one is a scaled copy of this one. Letter A. If AE, so from here to here, equals 4, how long is the corresponding distance in the second figure? So from here to here, what does that equal to? Explain or show your reasoning. Well, the way that I would do this is I'm going to say, how do I go from 6 to 15? 6 times what equals 15? If I don't know, I can grab my calculator and just put in the opposite. The opposite of multiplying is dividing. So 15 divided by 6 is 2.5. So the scale factor is 2.5. Scale factor is 2.5. So 6 times 2.5 is 15. Let's check it. 6 times 2.5 is 15. So 4 times 2.5 is 10. 4 times 2.5 is 10. So HL is going to equal 10. Okay? That's how I figure out this one's 10. And then it says if I to K. So if from I to K, from here to here, is 5, how long is the corresponding distance? Well, the corresponding distance is BD, so BD equals, we don't know. To go from here to here, we need to multiply by 2.5. To go the opposite, we'd have to put 2.5 over 1 and do the reciprocal, which is 1 over 2.5. So 1 over 2.5 is 0.4, or 4/10. So we're going to multiply by 4/10. So 5 times 4/10 is what? 5 times 4/10 is 2. So the length from here to here is 2. BD is 2. Okay? That's page 39. Okay? All right, so we're going to be on page 40, and it's 4.3 scaled or not scaled. Here are 2 quadrilaterals. Here's the first one, the second one. May says that polygon ZSCH is a scaled copy of polygon XJYN. But Noah disagrees. Do you agree with either of them? Explain or show your reasoning. Well, let's compare the sizes. From here to here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. 1, 2, 3, 4, 5, 6 by 6. This one is 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4. 6 by 4. So how do I go from 6 to 4? 6 times 2/3 gives me 4. So 6 times 2/3 equals 4. And if you want to know how I got 2/3, you do 4 divided by 6, and it gives you 66/100ths. Repeating, you know that's 2/3 is a fraction. Okay, so then I'm going to take my 9. 9 times 2/3. 9 times 2/3 is 6. So far the measurements, but let's look at the angles. Let's look at our angles here. This goes across 1, and this goes across 2. This goes diagonal 1, 2, 3, 4, and this is only 3. So, that doesn't match up. Let's do the angles. Let's measure the angles. If you are to measure this angle and this angle, all 4 angles, they do not match up. So may have noticed that the responding distances are multiplied by 2/3 and thought that it meant the polygons are similar, but Noah is correct because the corresponding angles are not equal. So this angle does not measure this one. And if you were to actually measure it out, starting with this one. This one's going to be about 42 degrees, 42 degrees. And this one is 45 degrees. 45 degrees. So again, we're going to say Noah is correct because the corresponding angles don't match. Okay, then we're going to come down to number 2. Record the corresponding distances in the table. What do you notice? So xyjn, xy is equal to how much? Well, we already have that. From x to y is 6. From j to n, it's 9. This zsch, z to c is 4. And s to h is 6. Okay. And then it says, what did you notice? Well, for number 2, I noticed that it's a 2/3 scale factor, right? 2/3 scale factor is 2/3. Okay. Measure at least 3 pairs of corresponding angles. Using a protractor, record your measurements to the nearest 5 degrees. What do you notice? Well, I measured these 2 and I said, they're not correct, so they don't match. 42 degrees does not equal 45 degrees. You could measure these 2 corresponding, these ones, and these ones, and they also would not match. So, not equal. They're not equal measurements. Okay, that's page 40.